Okay, so if we have, we're going to talk about sum and difference identities, and we use these when we have an angle that's given to us that is not on the unit circle, so not a 30, 45, or 60 degree reference angle, but can be split into two of those. Like we can use two of them to add or subtract to obtain the angle that we're looking for. So these are the sum and difference identities. So let's say that they ask us for sine of 195 degrees. All right, so that means I'm here, 195. 195 minus 180 means I have a 15 degree reference angle. So that's really not one of our special triangles, but it is the difference between two of them. So I'm going to use 195 and what I know about my unit circle and try to find two angles that I can add or subtract to get to 195. So it doesn't matter what you use, makes absolutely no difference. I'm going to show you addition first. So we're trying to find this side length. All right, so sine at 195, I can split to 150. Sorry, my pen wasn't working. And 40, not 145, 45. So 150 degrees plus 45 degrees gives me 195. So I'm the same thing. Now I'm going to come over to my formulas, and I have a formula for adding two angles. So the formula says sine alpha plus, or this one uses A, sine A plus B equals, so A is the first angle, B is the second angle. So sine of my first angle multiplied by cosine of the second angle plus cosine of the first angle multiplied by sine of the second angle. So I'm going to do that here. So I have sine of the first angle multiplied by cosine of the second angle plus cosine of the first angle, sine of the second angle. Okay, now I use my unit circle to find the sine of 150, which would be 1/2, the cosine at 45, square root of 2 over 2, the cosine at 150, which would be negative square root of 3 over 2, and the sine at 45. So I'm just going to draw those over here, 150 degrees, and you can use your unit circle if you want to, or you can draw it. 150 is a 30 degree reference angle. That makes sine 1/2 cosine negative square root of 3 over 2. This is 1. And then also a 45 degree reference angle, square root of 2 over 2, square root of 2 over 2, and 1. So I'm pulling, and you can draw these triangles and write the information to the side and then fill in if you want to, definitely. Alright, so then I clean up. So I have square root of 2 over 4 plus a negative square root of 6 over 2 over 4. Multiplying the bottom of my fractions together. And then I'm going to add. I already have common denominators, so I add the top. I can't add those radicals because the numbers underneath are not the same, and I can't simplify them either. So the work is deciding what angles you're going to use to add or subtract. By the way, if I'd chosen two angles to subtract, I would end up with this exact same answer. So we have found this side of the triangle, square root of 2 minus square root of 6 over 4. To find the cosine of the triangle, I would do the same thing but use the cosine formula. And I already have my triangles drawn, so I can just plug and chug. And I would do the same thing with tangent. right? So it's the same whether they ask you for sine, cosine, or tangent. Number one, find two special triangles that add to be the value that they've given you, or subtract to be that value. And then number two, draw your two triangles and figure out what sine and cosine are, or tangent if you're using sum and difference of tangent, and then plug the values in and simplify.